Hi there once again and welcome back. In the previous videos we talked about the V-belt drives, and we have learned that belt drives in general, it's one way of transmitting power from one shaft to another through the use of pulley and belts. And we have also learned that when we vary the diameter of the pulley, we can actually change the output speed. So we can either speed up the output shaft, or we can also speed down. Okay, and the V belts were just actually one type of belt drives, but before the invention of V belts, before its development, what was actually used, or what was used prior to the development of the V belts were the flat belts. Okay, and flat belts, it's another type of belts, and basically from the word itself, flat, so that means that if you cut this section along the belt, what you see is just simply something like a rectangular cross section that's very thin, okay, compared to the width of the belt. Okay, so the development of V belts, that's most likely it was because of some disadvantages or downside by the downside brought about by these flat belt systems. Okay, so probably they need a more compact drive, and probably a higher output, but with less space that will occupy, so that's why. But there are still advantages. There are still advantages for the when using these flat belt systems, and as well as because of the development in the materials. So there's also advancement in the materials. So even though we have these thin cross sections, it can transmit more power, okay, because of the technology in the materials. Okay, so now let's go to this lecture handouts that we have. And right here in this figure 10-1, this figure right here is taken from the website by Forbo Movement Systems. So I also suggest that you take a look into the website, and also see the other products or other types of flat belts, and the procedures, and also their catalogs about these flat belts. Okay, so just like as what we did in our in the V belts discussions, we will also talk about the types and specifications for flat belts, and even for these flat pulleys. And also we will talk about the computations and other requirements and provisions, as well as the design procedure. Okay, so again, take note that this is primarily we are basing our discussion based on BAS 302. Let me write it here. This is Philippine Agricultural Engineering Standards 302/2000. Okay, so that's our main reference for this lecture. Okay, now for the introduction. Now there are actually advantages as well when using flat belts over the V belts. So first and foremost is that it is more flexible. Right here in this figure 10-2B, you will notice that this is the cross section of the flat belt, right, and this one is the V belt. So in terms of cross sectional, in terms of the size of the cross section, this is more. This is actually smaller as compared to this, and therefore when it is smaller, then we can say that it is more flexible and can accommodate longer centered center distances. Okay, and second, they are more or they can accommodate cyclic bending. Okay, so cyclic bending, it's a fatigue loading, so which means that if it is more tolerable for cyclic bending, then that means that it can have longer service life. Okay, so longer service life as compared to V-belts. Okay, so that's the second advantage. And the third advantage is that when you buy lengths, okay, when you buy lengths of flat belts, it's actually I mean, you can actually customize it depending upon the length that you required. So compare that to the V-belts where it has a standard length already, like for example the B51, right? So that means that the pitch length or the circumferential length is 51 inches, whereas this one, for the flat belts, you can cut at whatever lengths that you desire. Okay, and just do some splicing for the connection. Okay, so that's it. That's the comparison between V-belts and flat belts. And right now, let's go to the flat belt construction. So just like the V-belts, it's just simply composed of some materials, rubber materials, or other types of materials, I mean appropriate materials, and some tension members right here. So it can be a fabric, or it can be a sheet or foil, or it can be cords right here. Okay, so that's it. And for the applications of the flat belt drives, we can use the flat belts for open drive systems, just like the V-belts, but we can have it with a longer center distance, and we can also have quarter turn drives or something like this, a spindle tape drive. Okay, so if you have spindles right here, and you have here your driver pulley, okay, so that's also possible for flat belts. And another one is for multi-pulley drive. So if you have multi pulleys right here, or many other pulleys, then you can do that with the V-belts too, but the flat belts can also accommodate that. Okay, and what else? It's also used for conveying applications. Okay, so now let's talk about the types and specifications for flat belts. So in our PAS 302, it specifies only two types of materials. So we have this rubberized fabric, and we have this reinforced nylon cord. Okay, so this fabric is actually it's a fabric, but it has some surface that's rubberized. Okay, so it has its applications for nylon cord. It has also its applications. Okay, so let's see right here, or let's read right here. It says here that rubberized belting is made from fabric or cord impregnated and bound together by vulcanized rubber compounds, and the advantages are high tensile strength to hold metal fasteners satisfactorily, and resistance to deterioration by moisture. Okay, so rubber belts are used in places exposed to the weather or the action of steams. Okay, and the specification for this rubberized fabric is it is specified in terms of ply. So ply is something like related to the thickness, but this one is in terms of ply rather than in mm. Okay, so it could be 3 ply or 4 ply or 8 or 10 ply, right? And another specification is the type of rubber. So the fabric belt, you can have, actually this is in our PAS, and it specifies fabric belt, hard fabric belt, and rayon cord belt. Okay, so these are just type of the materials. And for the nylon cord belts, it's just specified in terms of thickness. So the thickness is we can have light, 1.5 mm for light capacity, or we can have 2.5 mm for medium capacity, or 3.5 mm for heavy capacity. And also we need to specify the width and the length and the power ratings. So right here in figure 10-5, we have here the different sizes for this rubberized fabric. So this is the width of the belt, right? And the thickness corresponds actually to the number of plies. Okay, and for a nylon cord, there's actually another term, or there's a term there in our bias that they mentioned about this endless cord. So instead of having a customized length, it has or it comes with a specified length, just like the V-belts. Okay, so let's move on now to the types of pulleys. Now for the pulleys, pulleys for flat belts are usually specified in terms of classification. So how do we classify that? It can be classified by construction. That means that construction of this pulley. So if it is solid, meaning one solid construction, or it can be split. So this one is a split type. And in terms of shape of external peripheral face, so that refers to this. So we can have a level face, or we can also have a crown face. So the use of this crown face actually is because it may be for some situations, or for some configurations or installations, maybe it's there. There's a problem of slippage of this belt along this direction. So in order to solve this problem, then one way is to provide a crown. Although there were situations, or there were installations where they use flange right here, and so flange. But the use of flange is that if this is misaligned, if the belt is misaligned, so it will actually it will wear on one side or this side. So depending upon where it touches. Okay, so that's one of the problem of this flange. When using a flange pulley. Okay, what else? Now for the computations, it's almost the same as the V-belt drive. So we can have this speed diameter relations and speed ratio, which is just given by this expression or equation right here. And the speed ratio is just the end of the driver divided by the driven. For the belt length, for open, just take note, the negative sign right here, that's the open drive, and the plus sign, that's for a cross drive systems. And for the arc length and this angle, and as well as the radius, then here's the relation. For the center distance, it's almost the same, but I've just included right here the belt length for other drive configurations. Alright, so right here I have included here, like for example, we have a cross belt drive. So here's the illustration. And recall that the use of this flat belt drive is if we have this direction for this clockwise direction in the driver, right here we will have a counterclockwise direction. Okay, and the equation is just almost the same as the open drive, except that it has this plus sign. All right, and for a half cross belt drive, we have here the here's the direction of the axis of this pulley, and it has a, I mean, this axis is perpendicular to this axis. Okay, and the equation for the length is, you will notice that it's almost the same right here, except that this term, this d1 squared plus d2 squared all over 4c. Okay, so again, as I have mentioned in our discussion in V-belts, this is actually the main lengths, and these are the lengths. Some values right here. I mean, you'll get some small values right here just to correct the distances. Okay, so as you can see, this 2c is just simply the length of this two center distance, right? So it's like this length and that length, and this d1, I mean this second term right here, is just the this d1 plus d2, I mean half of the circumference plus half of this circumference. So that's it, and this third term is just what I call for correction. I mean, you will get some values right here when you compute, but maybe in the exam, then if the choices they're not that close to each other, then probably I'll just try to use this. Okay, and for perpendicular belt drive, we have this diameter 1, I mean this pulley number 1 and this pulley number 2. These are, let's say, here's our input and here's our output shaft. The equation is just simply this one. So it's like this, except that you just have to consider another length right here. Okay, and the second term, is just notice that this d1 plus d2 plus the diameter of the third pulley. For the design power, it's also the same. Again, design power means that we have to take into account this service factor, and where do we get this service factor? It's from the tables or manufacturer's catalog. And for the belt selection, we will have different procedures for rubber cord belts, or this is just the same as the rubberized fabric. And for nylon belts, here's our nylon belts. We'll have another we'll have a different procedure for that, and we'll also have power tables for both the rubber belts and a separate table for these nylon belts. And for the belt width, we have these equations. This is just something like equal to the how do we know how many number of V-belts do we need. So right here is just, instead of number of V-belts, this is in terms of width. So how wide would our flat belts be if we have this design condition, or this value for the design power. Okay, so this is given by this expression PD. This is the design power, and this K right here is the power rating of the belt. So we can obtain this from the table, and take note, this is watts per mm, and this C right here is the arc of contact factor, or correction factor for the arc of contact. And so if you check the unit, this one is in watts or HP, and this one is watts per mm. Okay, so what you get here is just simply mm in terms of the that's going to be the width of the belt. And For other requirements and provisions, we have this pulley face width. Okay, so here's our illustrations right here, and we already discussed this, or we have already encountered this in our topic in design of bucket elevators in another course. So this is our belt width, right? So this is our belt width. Here's gonna be our pulley width, right? And you see this clearance right here. So that is actually specified in the PAES and even in other textbooks or manufacturers' catalogs. You see, so what it says is that if we have a belt width that's under 305 mm, or this is 12 inches approximately, then the allowance is 25. So it only says 25 mm. It doesn't say 25 mm in this side only, or 25 mm in this side. So I think it will also apply to, if I mean the total of the allowance should be 25 mm. So that means you can have this 12.5 and this one is 12.5. Okay, and if you have a belt width that's 12 inch to 24 inches, so the allowance is just simply times 2. So this is 51 mm or 2 inches. And if you have over 610, over 24 inches, then you have here 76 mm. This is just 3 inch, or in terms of inch, and this is 1 inch. By the way, I'd like also to emphasize that we also have to work with this inch units, because sometimes, or usually, when you go to a hardware store or to a supplier, they might work in terms of these English units rather than in metric units. Okay, so that's it. Now for the connectors, another characteristics for these flat belts is the connectors. So since we can actually customize the length, then that means how do we connect both ends? Okay, so one way is through this steel belt lacing. So you have these lacings right here. That's something like a pin, or I don't know, maybe a clip or something. And another method is through this bolted plate fastener. So if you have these plates and you have these bolts, and it's also possible to have, for example, we have this both ends, right? Here's our cut. So it's also possible to provide or to use some splicing right here, okay, lap splicing. And for nylons, actually there are many ways as well. You just have to check the manufacturer's catalogs on how they recommend regarding these connections. Okay, and finally, regarding this other provisions is the safety. So I think I forgot to include this in our discussions in V-belt drives. But in terms of the safety, it just specifies that drives must be enclosed with covers. So what that means is, if we have this belt drives right here, and we have here the belts, and let's say here's our shaft, and they're all rotating. So what it says is that we need to provide a cover. Okay, so at least we can prevent some injuries or accidents, and also protect this belt drives from external factors that could affect the functions. Okay, so that's all. And lastly, we have to talk about this design procedure. And again, as I have always emphasized, that this is not the absolute procedure, because that actually depends upon the design situations or the given parameters. So this is just I don't know, maybe we can just use it for some situations. Okay, but the first step that I usually do is that I first obtain the necessary information, like for example the power requirement or the type of the driven equipment, and even the type of electric motor or the source, because sometimes in terms of the service factors, that depends upon what type of electric motors you use in the situation, and also the sizes of shafts, so we have to check that as well, and the speeds, shaft center distance and drive arrangement. Sometimes this is given, or sometimes this is sometimes you need to compute for this. And available lubrication, I think this does not count. This should be for chain drives. Okay, so once you have the necessary information, then you can solve for the design power and for other parameters, like for example the belt speed. Okay, so belt speed, this is V, this is the linear belt speed, this is pi d n, right? So if here's our pulley, the speed right here, the rotational speed, that's the RPM, right? But the linear speed right here of the belt, that's the V is equal to pi d n. Okay, and also the diameter, if you can find using the speed diameter relations. Okay, and then for the belt selections, then just take note that when we specify belts, we need to specify the belt materials, the belt thickness or number of plies, the belt width, and the belt length. We need to specify that. Okay, so the choice of material, that actually depends upon the situations. If we use, the characteristics of these rubberized fabric is, it says that it is resistant to deterioration by moisture, and for nylon cord it says oil and heat resistance. So it has, so they have their own applications. And for the belt width, we can use this equation, and we need tables for this. How do we find this this K value is through this table. And for the number of plies or belt thickness, we just have to refer to the tables. And for the belt length, we use the belt length equation. And for the pulley selection, what we need is to specify the diameter and the width, and also the classification in terms of if it is level or it is flat or it is split or solid. Okay, and also in detail, we can the width of the pulley can be obtained using this equation. So just recall the table regarding the allowance. That's the belt width plus the allowance. All right, so now I think we still have time. By the way, I have included in our appendix in our lecture handouts the summary. I think this is the summary. Okay, this is not included. Summary of PAS 302 tables and figures. So it lists down here table 1 to 10, and the description, and also the involved quantities, and as well as the figures. Okay, so before we go on to sample problems, I'd also like to discuss to you the contents of this PAS 302 2000, but I guess I'll do that in the next video.